Okay, so we're going to have another look at a question from the topic of electromagnetism. So here we're told an electron circles in a ring of radius 250 meters with a period of 50 microseconds. So find the electron speed and then calculate the magnetic field strength required to keep it in its orbit. Okay, so we're going to start with the speed. Well, this is just a big circle, just moves in a circle. The radius, we are told, is 250 meters. Now we know how to find the circumference of a circle. The circumference of a circle is 2 times pi times the radius. So this will be 2 times pi times 250, which will be 500 times pi. Now we're told that the period is equal to 50 microseconds. If we convert this to seconds, 1 microsecond is 1 times 10 to the minus 6 seconds. So 50 is going to be 5 times 10 to the minus 5 seconds. So our circumference is in meters and our period is in seconds. So we want a speed. That's simply going to be the circumference divided by the period. It's going to be the total distance it travels in one loop divided by how long it takes. That will give us our electron speed, or our tangential velocity. So the velocity in this case is going to be 500 pi divided by 5 times 10 to the minus 5. And this answer, if we put this in the calculator, this will give us something in terms of meters per second. So 500 times pi divided by 5 times 10 to the minus 5. That is 3.1415 ... times 10 to the 7 meters per second. So very, very fast. The reason it's so fast is it's a very large circle and its period is incredibly tiny. So it's moving in a huge circle really, really fast. So this is the answer to part A. Now for part B, we're told to calculate the magnetic field strength required to keep this thing in orbit. Okay, well, if we have a particle orbiting, we know that it needs a centripetal force. We know centripetal force is mass times velocity squared over radius. In the case where the uniform circular motion centripetal force is provided by a field, then the force from the field, which we know is the charge times the velocity times the field strength, is going to be equal to the centripetal force. So these will be equal. This gives us mv squared on r is equal to qv times, this is not an E, this should be a B, sorry. B is the magnetic field strength. We can divide both sides by V. This gives us mv on r is equal to q times b. Now we know quite a lot about this problem already. We know the radius, so we know r is 250 meters. We know the charge. We know the charge of an electron is about minus 1.6 times 10 to the minus 19 coulombs. We know the mass of an electron is about 9.1 times 10 to the minus 31 kilograms. We've just calculated the velocity. We said the velocity is about 3.14 times 10 to the 7 meters per second. The only thing we're missing is the field strength. So we can rearrange this, divide both sides by q, we get the field. It's equal to the mass times the velocity divided by the radius of the circle times the charge. So we get B is equal to 9.1 times 10 to the minus 31 times the velocity, tangential velocity, 3.14 times 10 to the 7, divided by the radius, which is 250, times by the charge, which is minus 1.6 times 10 to the minus 19. You'll notice the minus doesn't really need to be here because we've not been told which direction to make the thing rotate. We've just been asked what field strength is required for it to rotate. The positive of this number will be one orientation of rotation. The negative of this number will be the other orientation. But both are fine because we've just been told calculate the field strength required to keep it in orbit. And we've not been told what the orientation is at the start of the question. So 9.1 times 10 to the minus 31 times 3.14 times 10 to the 7. This is all divided by 250 times minus 1.6 times 10 to the minus 19. When you have these expressions, you've got to check everything is put into the machine or calculator very carefully. This gives me the magnetic field has to be minus 7.1435 times 10 to the minus 7, and this will be in Teslas. And this is the answer that we're after for part B. You could also have the positive of this. It would just spin the thing in the other direction. So one way will be clockwise, one way will be anti-clockwise. Technically, both answers will be correct because it didn't specify the direction.